Hi everyone, this is Safa. Welcome back to our Control Systems Fundamental series. In this video, we learn how to simulate and analyze the impulse response of a first-order system in MATLAB. We'll not only plot the numerical response using MATLAB's impulse command, but also compare it with the analytical expression to verify the result. Okay, let's get through the code step by step. Here, first, we clear MATLAB's workspace and figures with a CLC clear and close up. Then we define system parameters gain k equal 1 and time constants tau equal 2. Using the Laplace variable s, we define the transfer function g equal k tau s plus 1. Okay. The command dispg prints the transfer function. And then we create a time vector from 0 to 12 seconds. And MATLAB's impulse GT calculates the numerical impulse response and also compute the analytical impulse response given by HT. Okay, plot both. Both curves are plotted together. The solid line is MATLAB's result and the dashed line is the analytical formula. Okay, run. And here, transfer function TF with properties and figure 1. As you can see, the two plots perfectly overlap. The impulse started from 0.5 and decays exponentially to 0. That confirms our MATLAB result matched the theoretical behavior of a first-order system. And that's it for our third video. You now know how to simulate the impulse response of a first-order system and verify it against the analytical expression. In the next video, we'll study how the time constants affect the system response speed. Thanks for watching and see you next time.